All right, so kind of game plan for today. We'll cover very little kind of new material, kind of what I was hoping to get through last week, but we didn't quite make it. Then I'll kind of move to doing a couple problems that I think it would be good to work through and just see if you have any questions on those. Then I'll probably take questions from you and probably save a little bit of time at the end. Go over the paper we were going to go over Thursday, but I wasn't paying attention to time. So we'll kind of talk about that a little bit and kind of talk about maybe potential questions that could be kind of coming from this linear regression stuff. So try to kind of build up to this point. We'll kind of save a lot more of the interpretation stuff for after this exam, but I want to make sure we have kind of a base understanding of kind of what we're doing with this regression analysis. Okay. So we left off kind of talking about how funds are generated to pay for stadiums. We then started kind of talking about different types of taxes. We want to tax inelastic goods to kind of increase revenues, but we'll kind of look at a couple other issues. So one of them is this kind of all or nothing. So you think about once a team is, they're making a bid to have a stadium in their city, right? They can't just say, yeah, we'll host 6 of your 8 games, right? Like they're kind of agreeing to host all of them. And so, or if a team is already located in a city, what kind of power might they have so that they need all of their games to be played in the city, even if the city only wanted half of them? How can they encourage that city to kind of pay for the whole thing? So I think I left this slide open. So I wanted to kind of draw this out. So let's think about the number of games and then kind of the dollar amount associated with each one of them. So there will be, let's think, how do I want to make it easy? So this is just thinking about if a team is making an agreement to kind of have the stadium in their city, how many games they're going to host of that team's games. Right? Now we know inherently they have to host all of them, but we'll kind of see how this works. So let's assume, just to make it easier, let's just assume some constant marginal costs. Let's say we've got the demand for those games, which just reflects the marginal benefits to the city. So, let's say even if the city is the only one proposing to kind of host this team, so maybe they're the only city, they kind of have this monopoly power over the team, right? If I'm your only choice, I know that I kind of have power in that market. What they would like to do is kind of, and we'll call this, I guess, the optimal number of games here. They would like to set the number of games here. So the problem is, let's just say, to make it easier, that we need, and we'll make it, it's an NFL again, so 8 home games, right? Or I don't know, 9 now because they've got uneven numbers, but just for the sake of this example, we'll kind of go with the old scenario where they have 8 home games. So even though this is the optimal point for the city, right? So we know that they'd be willing to pay kind of this much per game. So whatever, I think about this as like the price that they're ultimately going to pay per game, right? They'd be willing to pay up to this point. So the team looks at this and says, okay, well, I know that the surplus, right, to that team is the area under the demand curve up to the price that they pay, right? So remember, think about consumer surplus. Anytime we think about any surplus, it's just the differences between the benefits, marginal benefits, and the marginal cost. For consumers, the marginal benefit here visually, well, demand reflects that. And then the marginal cost, well, that's going to just be this kind of price per game that they pay. So what can happen is this team says, look, we need you to play all 8 games. And we realize that if we play all 8 games, right, if you keep paying this constant price per game, this will also be part of your consumer surplus, right? So it's the difference between marginal benefits and marginal costs. And generally we think that, if we just go up to the optimal point, like surplus value should always be positive or up to at least 0. But if we were forced to kind of continue to host the games past this point, now the marginal cost is greater than the marginal benefit. So it's kind of like this would be our losses. So if I'm a team and I need all 8 of my games to be played in this city, even if they are the only city and have monopoly power, why can I guarantee that I can get them to play all 8 games? Because I tell them it's all or nothing, right? So here the scenarios are: if you host 0 games, what's consumer surplus there? 0, right? So think about this as 0. Okay. Kind of call this area 1. It would have some value associated with it if you had the actual linear kind of functions here, and then we'll call this area 2. Right? So if instead, right, all or nothing, if they decide to host all of the games, what is consumer surplus? Well, it's going to be area 1 minus area 2. And as long as that's greater than 0, they're better off hosting all of the games. Right? So even though if they were the only city and they have this monopoly power of the team can turn around and say, well, look, we can't play in the league unless we play all of our games. So you either agree to all of it or absolutely nothing. Right? We'll hold out and wait for another city to kind of give us a proposal down the road. Okay? And the reason why they know that the team or the city, I shouldn't say team, the city is going to agree to that is because the all is still better off than nothing. Now, if we get a scenario where area 2 gets larger than area 1, what's going to happen? So if area 2 ends up larger than area 1, if in order to compete, I have to host all of my games, I'm going to have to find a new city, right? Because this city, if this ends up being, area 2 is larger than area 1, now the all is a negative payoff, where the none, 0 games, would be 0. So they'll choose 0, right? And they'll let that team go find another location. But as long as that kind of area 2 is less than area 1, we know that the city would agree.
How would there be differences between those two if marginal is
Oh, how do I know that these? It's all going to be dependent upon where marginal costs would be, right? Because I understand what you're saying. So you know that it's always twice as steep. So you would always know the relative size of this area to this area, but it's also going to depend on the slope of the demand curve as well. Like just the initial start, like the initial slope. And that initial slope relative to what marginal costs. Now, in practice, this is going to be a little more difficult because it's likely that our marginal costs are increasing. Just kind of simplifying the model a little bit for right now. And if we have increasing marginal costs, then you can imagine you're always going to end up, like if this was like something like that, you're always going to end up with a little bit higher of a location. So you're always going to guarantee that second area will be smaller than the first. But we've simplified it here just with constant marginal costs. And I won't ask you like on the exam to put any dollar amounts to these. I wouldn't give you linear demand equations and have you determine what these areas are, more so just knowing the idea here. I know the concepts.
What is the price for? Like, them like buying?
So you can think about it as like inherently, they're never actually going to, it's almost like buying blocks of tickets. You could back out if I'm getting 8 tickets and I'm paying $800, I'm paying on average $100 per ticket. It's kind of the idea here, right? They're going to agree to host a number of games. That's going to work out to some average price per game that they're going to pay. But whatever that worked out to be, that would be kind of like their marginal cost, right? Because they're buying like the block all at once, and so we kind of think about that as their cost per game. So every additional game would incur whatever that price would be, and that's how we could use that for our marginal costs. Questions on this model? So there's one thing we didn't quite get to. The other one I'll go over kind of quick so we have time to work through some more problems. This is just something interesting that a lot of stadiums try to do. So we've talked about these positive externalities. So a lot of cities will try to evaluate what the benefits to their city are. And then it's not just going to be what the benefits are next year. It's going to be for the length that the team is going to be located in that city. So you can imagine we start looking at future benefits and discounting them by whatever that kind of rate of return would be, right? And so we can really come up with the total valuation by looking at across the entire expected life of the team being in that city, kind of discounting the benefits in each year by how far out they are to give us kind of this net present value. So a lot of cities will do this to determine like, well, then if we can put a net present value on the benefits of the state, and we know we'd be willing to pay up to that amount, right? It gives us like some, I guess, I don't say starting point, but it gives us some idea about where we should not be willing to pay up to. Sorry about that. I forgot to turn off my volume. excuse me. So let me see if I can get this to pull up. Sometimes I feel like my links will. I guess I'll copy and paste it. So we'll go here. So this is, I put a kind of a link up there. It's kind of interesting. This gives you an idea. I forget, this was like the location of a plant. So this isn't a sports example, but the idea of what these cities do is try to put a value on whatever they're proposing. So here it was some type of electric plant, and they were thinking about the negative externalities that would exist. And they were trying to get a valuation on the negative externalities. It's a little bit easier to know how much additional benefits this plant would bring in. Here, the externality, what they were trying to use this survey to get at was these negative externalities exist. More often than not, the cities are kind of doing the reverse, right? They kind of know what the costs will be. They're trying to get a valuation of the benefits. Okay? But they ask these kind of goofy questions and try to tease out exactly how much people pay. Like here, it's like, would you be willing to pay $1 a day to prevent that team from coming to the city? Or would you be willing to pay this much, right? And so by looking at that willingness to pay and kind of where people, stop, they can get an idea about what the value of these externalities are would be to each citizen, and then kind of multiply that by the number of citizens they have. Now, is this perfect? No, right? We're asking people their beliefs, their opinions, right? They're not really going to have to actually pay, right? So it's very easy to say I would pay $100 a day to keep that evil coal plant out of my city. It's another thing to actually pay the $100 a day, right? So it's a little bit, I tend to think this is a little hokey, but this is something that a lot of cities do use to try to get an idea about the valuation. One thing that we had started to talk about last week as well was this idea of like hosting these big events. And so one thing that can exist in hosting these big events, and I might have already mentioned this a little bit, is this idea of the winner's curse, right? So it kind of ties in nice with the invariance principle. But if everybody's proposing like to host these events, so let's say it's the Olympics, right? And let's just for a second assume that cost to hosting will be similar, right? They may not be, and it would complicate the matter further, but even if the cost to kind of providing or kind of hosting that event, that the Olympics, were the same across all cities, who's going to be the city that bids the most for it? Well, if the costs are all the same, it's going to be whoever values it the highest. Right? Now, in practice, it's going to be whoever has the greatest difference between their benefits and their costs, right? But maybe it gets harder. Like some cities may have lower revenue from hosting, but higher costs. Other cities may have higher costs, but low revenues. And so we can kind of just think about this scenario where everyone's costs are the same, then it really comes out to who values the most will be the one who bids the highest. And in practice, who values it the most is who has the biggest difference between the expected revenues and the expected costs. So it's really kind of the same idea, that the person who values the most is going to be the city that bids the most, right? They're going to be willing to pay up to a higher amount. Okay. So the problem is who's likely to have the highest valuation. So if we now assume that costs are still constant across these cities, whoever was the most optimistic about the additional revenues that hosting that event would bring in, they're going to be the one that has the highest valuation and will bid the highest amount. The problem is if they were very optimistic, potentially revenues don't come even close to what they thought they would be. So you have all of these cities who are the most optimistic, and we can think about it as, just to kind of put a little bit of visual. We're thinking about everybody's marginal costs are the same, then really they're making a decision based off of the difference between marginal benefits and marginal cost to hosting this event. Whoever is the most optimistic about the marginal benefits is going to have the greatest difference and will be the one that would be willing to pay up to the highest amount. You can imagine, maybe one city's got a difference of 10 million, another one of 20, 15, 12. Well, the city who was the most optimistic about the additional benefits, they're going to be willing to pay up to a much higher amount than these other three cities. Okay. Well, now what the problem is, let's say that this person was actually the most, realistic about the outcomes. So they overpredict the benefits by $10 million. So maybe we'll call this city A, B, C, and D. So city B, kind of maybe they'll bid, they say, well, look, I kind of know what the other city's valuations. I would pay up to 20 million, but I know I can get away with just paying 16 million, right? Because nobody else is going to top it. So what's the problem? Well, they bid 16. they think they're going to get 20. So their kind of belief, or I guess we could call this expected profits, would be $4 million. But then when it comes in and city A was the one who actually had the correct beliefs, now the actual kind of realized profits end up being negative, right? Because whoever's the most optimistic is the most likely that when they get the bid would actually end up kind of overpaying. So that's the idea behind the winner's curse. So a lot of times you see these cities who land the bid for the Olympics or World Cup. It may be that, you see a lot of stories that it actually isn't profitable for them. Well, maybe it's not profitable because they were the most, right? They were the most unrealistic about their own costs and benefits. Like in practice, I just did an example where I was just thinking about cities having unrealistic beliefs about the marginal benefit. They may also have unrealistic beliefs about the marginal cost. So they're putting a bid to host this, right? These costs, right? Maybe it's not just my bid, it's maybe my, I thought I could do it for 16 million. I end up only actually I have to pay up to 20 million for it, right? And so you kind of have perceptions of both things that could cause this winner's curse. But the revenue one is, I think, the easier avenue to kind of understand. Okay. Is this kind of clear what I'm getting at here? Any questions on this? Okay. So we see this a lot. I started talking about this last class. I skipped ahead a little bit. So we had the stadium financing. And one thing, I showed you some of the tables, but this is, and I don't know if this will even pull up. If this will pull up either. So this is like the old Deadspin days before they were bought out. So let's go down here. I think they should be a graphic unless they got rid of it. Oh, where is it? Oh, it might be too old. They might have gotten rid of it now. Or they just won't let me see it. Let me see. Maybe it was the other one. Now I know this is it. So they used to have this really cool graphic. I guess they've taken it off of the article now. But it was showing like the time progression of how cities were paying for the stadium. So if you go back like to the original days, and I think they specifically were looking at Major League Baseball, if I remember right, maybe they had all stadiums. You go back, 100 years, what percent of the stadium were these cities paying for? Primarily zero. I think so the first, 8 stadiums or whatever it was built in Major League Baseball had all zero subsidization. Over time, you kind of see the percent that the cities pay for starts to grow up until today, which was some of the newer data I showed you last week, which is that now you've got some cities paying for the entire thing, subsidizing the entire stadium, right? So it must be that there's some belief over time that these positive externalities are even greater than they thought, because the cities are willing more and more to pay for larger amounts of the stadium. The only way that makes sense is if that stadium's going to bring in large positive externalities. Okay. So that was kind of I'll try to get the right link and maybe put it up on Canvas. It's a really cool kind of little graphic that goes across like the last 100 years. So how are we getting these subsidies? We said that we're going to start taxing things, right? So a lot of times it's hotels. We kind of went through this. I think one thing I didn't mention was sin taxes are also used. So like things that you don't want people to use, you call them like sinful goods. You would kind of put a tax on those, and society feels okay about it because if you tax cigarettes and people pay more for cigarettes, they don't feel as bad for the individual. It kind of cuts down the use. So if you believe there's negative externalities to some of these sinful goods, then you would believe that you're actually deterring some of these negative externalities as well. The other reason where they're really targeted, they're socially very easy to tax things like cigarettes, alcohol. But as we kind of talked about last class, they also kind of have extreme inelasticities, right? So if we look at kind of the quantity and the price here. So let's say we've got the supply curve, and let's say we have just like a very, very inelastic demand curve. So the price is changing wildly, right? But the amount bought is hardly changing at all, right? So very inelastic demand curve. What's going to happen is when I tax this, I'll try to draw this in a good place here. So supply plus the tax, you can kind of see, okay, with the tax, people are going to buy a little bit less, right? But without the tax, kind of call this without tax. You can kind of see with that tax, the quantity reduced barely at all. Right? However, with that tax, I didn't draw that very pretty, but so no tax. And here's kind of the price with the tax. You can see the price that the consumer is going to pay has went up a hell of a lot, right? However, they didn't stop using much of the goods. So this is something we see with like cigarettes all the time. You can increase taxes a lot. You can put like $1 a tax on a pack of cigarettes. People keep buying pretty much the same level of cigarettes. They're just willing to pay that higher price, right? And so you kind of think about what's total tax revenue here. Well, the difference between, and I know I kind of didn't draw this perfect, but the difference between my supply curve and the supply curve with the tax is just going to be the value of the tax. When I'm thinking about like the difference between these 2 points, this is just the value of the tax. That was the size of the shift. Right? I then can think about, okay, what's the number of units sold after the tax? If I take the number of units sold after the tax times the value of the tax, you can kind of think about this as just government revenue. Right? So with a really inelastic demand curve, because the amount purchased barely goes down at all, right? Even though the price has increased dramatically with this additional tax, right? We are able to generate a lot of revenue, right? And the revenue is just going to be the value of the tax, which is the difference between the supply curve and the supply curve with the tax, and then the number of units I sell after that tax is imposed. Now, visually, that's kind of this rectangle here, but I think this is pretty intuitive, right? How much money does the government raise when they tax cigarettes by $1? Well, it's $1 times however many packs are sold. Well, technically produced, but yeah. Yeah.
So no deadweight loss.
So there is deadweight loss, right? So what surplus is being lost from having this tax? Well, if we didn't have the tax, we would have gotten out to this point, right? So just a very, very small sliver of deadweight loss there, right? And that really comes from, we did see some reduction in the quantity purchased, but not very much. So whatever that reduction in quantity was, every one of those units, we lost a little bit of surplus here. Yeah.
So it was like perfectly inelastic.
Perfectly inelastic, which I think I did last class, but right, if I just keep going up with this, what ends up happening with deadweight loss? That's when it goes to zero, right? If you had perfectly inelastic demand, well, then the quantity isn't changing at all. So if there's no change in quantity, we're not losing out in surplus because there's, we're not selling fewer than we were before.
Is the demand curve more elastic depending on
So, say that again?
like is demand curve more elastic? Like would the deadweight loss be more for alcohol versus cigarettes?
Oh, alcohol versus cigarettes. I think if I remember the elasticities off the top of my head correct, I believe it is because I think alcohol is slightly more elastic than tobacco use. It's like, I mean, cigarette use, it's something like, and they're all technically negative because you're talking about price increases, quantity. But I think it's like -0.1 for cigarettes, and then alcohol, I think, is like -0.3, -0.4. So they're still both inelastic, but alcohol is a little bit more elastic. Yeah. So usually, like cigarettes, if I had the choice, would probably be the better good to tax as opposed to alcohol. Also, alcohol gets kind of. So one of the things why alcohol taxes aren't as useful and why alcohol is a little more elastic is because there's substitution between types of alcohol. You don't really have like a perfect substitute for tobacco. Now, maybe this is changing over recent years when you've got, more things like CBD cigarettes and all this other stuff, but I doubt it just from my own limited knowledge, right? So any other questions on that before we kind of keep moving? So that's the idea that we want to tax these really inelastic goods because they generate a lot of additional revenue. Also, there's not really any social kind of, it looks pretty good politically. Oh, and this is the last thing I think before we got a couple of problems I want to work through. So we want to raise these taxes and we can put them on different goods and we can target inelastic goods and try to be horizontally and vertically equitable. But sometimes, right, I need the money quick, right? I need the money that for the team, I'm promising I can pay for it in the next year. So what can I do? So a lot of these cities will issue what we call municipal bonds, right? And they're tax-free, right? So you can kind of think about it as, you know, if I invest into the same, so let's say we've got corporate bonds, and then we've got municipal bonds. Right? So let's say I invest $100 kind of into my corporate bonds. The total payoff, right, is going to be my initial investment minus, actually, I can do X times 100 minus whatever taxes. So you can kind of think about it, and then, oh, I ran out of room. I'm going to rewrite this here. You guys have already got it also. Municipal bonds. So when you think about my return with a corporate bond is going to be whatever my initial investment is, right? And then I would call this the interest rate on the bond. And then whatever that payoff is, I'm only going to get to keep 1 minus whatever the tax rate is, right? So if the tax rate is 30%, I only get to keep 70%. However, that same interest rate, whatever amount X I'm investing on a municipal bond, it's tax-free, so I can make the same amount of an investment and the payoff is going to be higher, right? So people are always willing to pay a little bit higher for municipal bonds, right? And that's because they don't get taxed on it. Intuitively, that makes sense, right? I'm going to keep more of the money I make if the interest rate was exactly the same, okay? So when you think about here is, even if we had quantity of bonds here, and we'll think about kind of the price per bond. So there's going to be some general supply, and we'll assume that the supply of corporate bonds is the same as municipal bonds. But because we're looking at the same quantity, which of these is going to be worth more? So if yeah, the municipal bonds are always worth more. So I'm thinking about demand. Actually, we'll do 2 different colors here. So I go, here's my demand for my corporate bonds. So this is how many corporate bonds are sold. And this is the equilibrium price for those bonds. Okay. But at every single quantity, the value of that many bonds, if I had, I don't know, 10 corporate bonds versus 10 municipal bonds, the value of the municipal bonds will always be higher, right? So it's really just that I'm going to have a higher demand curve, which means the number of municipal bonds that could be sold is going to be greater than corporate. And I put bonds here. This should have been corporate here, right? And then this is our municipal bonds. So because they're tax-free, I can sell more of them and consumers are willing to pay a higher price, right? And now you could do things like play around with the interest rate a little bit. If you don't want, if you want to kind of equate these, you could actually do the math, but we're not going to worry about anything along those lines. All we're going to focus on is the fact that municipal bonds, because they're tax-free, have a greater marginal benefit to consumers. Remember, demand reflecting marginal benefit. So our demand curve for municipal bonds is going to be a little bit higher, which means the price that the city can get for these bonds and the number that they sell is going to be greater than if they were corporate bonds. Right? So this is they're very attractive relative to corporate bonds. So here I know that I can get a higher price. Well, maybe I actually just try to get the same interest rate, right? So that there's, I literally have the competitive advantage over corporate bonds, and it's a way we can generate funds very quickly, right? Because all these other, bonds are subject to the fact that they have to be taxed. Any questions on that for you? So, who wins out in this? Well, I mean, think about this, like these municipal bonds are put out there, anybody can purchase them. So the people that live in the city benefit greatly, right? Because all this money is coming into the city And yeah, it's going for the stadium potentially, but maybe they're just issuing municipal bonds even when they don't want to build a stadium. So these municipal bonds are very beneficial for whatever, the residents of whatever city issues them. Who's going to be losing out? Well, when you think about here, the government's pretty pissed, right? Because with all these municipal bonds, like the federal government isn't getting any tax revenue from them. Whereas if people had instead bought corporate bonds, they would have been paying into the, some taxes in the government. And so the cities like this, the residents like this, the government kind of national level, not as much, or even the state level, right? Maybe they're just avoiding state taxes. So that's another thing that we see cities do. I think that was all the new stuff I had. Unless you've got any questions on that, I can go over any of the problems in that practice exam if you've looked those and you have questions over any of them. Otherwise, I've got a couple problems that are similar to some of those questions that I think are kind of probably worth going through. But if anyone has a specific question, I want to make sure I kind of start with those. Yeah.
I was curious about like the layout of the exam.
Yeah, so just to go over some of the logistics, I guess. I have it pretty much ready to go. I got a little bit of what was you just asked me? It should be about, I've got 10 multiple choice questions and 5 short answer that have, some of them have a couple parts, some of them are just one part. It's a pretty even split in terms of the points. So a few more of the points are going to come from the short answer. I think if I remember right, it may not be exactly this, but it's about 40-60. So 60% of the points coming from short answer, 40% from the multiple choice. Okay. Think very carefully about the multiple choice, read very carefully, because those will honestly probably be a little bit more difficult in the sense that it's all or nothing. And then on the short answer, you can provide, you can get partial credit even if you're not completely sure on the whole problem, right? So I think being very cautious, I guess, when your answer are very meticulous on those multiple choice. And in the short answer, same kind of thing in a way. I mean, show as much of your work as you possibly can. I'm looking for ways to give you partial credit on the short answer. But I can only give you partial credit if I see your actual work. And even if it's not completely 100% correct, as long as you maybe hit a couple of the principles where you're kind of close to the right thing, I'm usually, fairly generous with the partial credit there if I see a lot of additional work and you were along the right lines. Yeah.
Could you give an example of that? It's like a paragraph question or like one sentence question?
So usually they're a little bit longer just to kind of set up, because I'll also put in a bunch of, so I've got a couple here, but I think there's a couple that might be a good example. You're good. Because there's also, I want to make sure that I might have to give you a lot of assumptions. So in this one, it gets a little bit longer because I'm telling you, assume both of them have the same constant marginal cost to win. Maybe in some problems, I also have to tell you, assume they have monopoly power, assume one is profit, one is win maximizing. So a lot of it's not so much, the longer the question, it's likely I'm trying to give you some things that simplify, right? Some assumptions that would simplify it. So we're really not having 4 or 5 concepts in one question. It's really kind of boiling it down to one. But these will be good kind of examples of some of the multiple choice questions you could see. Some of them are really short, like up here, what situation revenue, yeah. But it's a short question, but if I'm thinking about revenue sharing and then I'm thinking about 4 different combinations of win and profit maximizing, it probably makes the most sense to draw out a win market where I'm thinking about large, small market teams, profit versus win maximization, and then some revenue sharing there as well. Otherwise, I may, I think that would be the best way to tackle that problem. It's really kind of just draw it out, think about all the possible scenarios. Now you've just got one kind of visual in front of you. You can go through the 4 possible answers to figure out which one would competitive balance improve the most in. So, yeah.
I had a couple of questions.
Okay.
Number 4. I was thinking just with number 3, how it was asking how you can improve competitive balance.
Yeah, so we've got what?
Because if NBA is able to add revenue.
Yeah.
Small market team.
Oh, okay. So here we kind of have a unique scenario. So I chose this idea of subscriptions to kind of so the league is generating this revenue. So it's not revenue sharing in that they're taking a certain percent of every team's. So it should be like, you just have this new revenue source, right? So on this kind of a scenario, we're thinking about, and I think that was one where I told you, assume that they both face the same marginal costs per win, right? We've then got, did I do small, large market, or was it just win? It was small. Oh yeah, yep. So we've got small market teams. We'll just draw this dramatic so we can kind of really see the differences. We'll have large market teams. Okay. And we have the different profit and win maximization points, right? Now we know that the profit maximization points, or marginal cost is equal to marginal revenue, that won't be influenced at all by additional lump sum revenue given you from the league, right? That was the idea, that it doesn't change the marginal cost or the marginal revenue, it's just changing the total revenue. So once we had this revenue sharing, usually we thought about, well, it's coming, like if we take a certain percent of ticket sales, we would see a reduction in both these curves. But with this, it's just new revenue that's been generated by the league, right? So if it's just new revenue generated by the league, we're not going to see any shifts in the marginal revenue and demand curves for each team. So what we end up with is this lump sum amount, so that we've got these average total revenue curves. And they said, I believe it, they gave them to both teams equally, right? So I try to draw this, like it should be kind of the same, you know, the same kind of gap between the demand curve there and average total revenue, if we're thinking about they're all getting kind of the same lump sum. Now, here, my win maximizing points are actually going to be out where the marginal cost hits the average total revenue. It's just that before we didn't have any lump sums and we had nice linear demand. Demand was our average total revenue. Now our average total revenue is demand plus this, you kind of think about plus this revenue sharing amount. And really this RS, this should actually be like revenue sharing amount over quantity, where quantity is our wins. Right? You don't necessarily need to know that, but so the new point where profits will be zero is where our average total revenue curve hits marginal cost. So we can think about which of these scenarios would lead to the best improved competitive balance. Right? Well, prior, right, our win maximizing points would have been here. So we can do the easiest one first. If they're profit maximizing, this new revenue sharing does what? It's competitive balance. Nothing at all. They keep doing the same thing. If they're both win maximizing, they're both going to increase their number of wins. Right? And they have the same additional money. So we would expect kind of a similar increase, right? Because it's being shared equally to these teams. So they're both win maximizing. Yeah, they're both targeting a higher number of wins, but that gap hasn't really closed. Right? Yeah, but what if we have profit maximizing small market teams, win maximizing large market? Well, then with the revenue sharing, the gap actually gets wider. But what if the small market teams are win maximizing, large market teams are profit, large market teams stay the same, small market increase their wins a bit. So that's going to be one that closes that competitive or closes that gap, closes the gap in wins or improves competitive balance the most. And this is what I mean, where I just drew out one thing and I just thought, okay, the different combinations of these. Any questions on this?
Yeah, I didn't read it right.
Okay.
Yeah.
But I mean, this could be more complicated too. I likely wouldn't do this because without actual equations here, we couldn't really determine. But, you know, we do also want to make sure that we think about, even if teams are profit maximizing, this is a good one to go over. So if both teams are profit maximizing, and I do this revenue sharing, but instead of like this new revenue from subscriptions to some, you know, streaming thing, maybe they then take a 50% of the ticket revenue. So both of my demand and marginal revenue curves will shift, but which one's going to shift more? Yeah, 50% of a larger value is going to be a larger amount of a shift. So even if they're both profit maximizing, if I institute a revenue sharing where I'm taking some of existing revenue, I actually know that these curves are going to be closer. because that large market team shift is going to be much greater than the small market. So even if they keep profit maximizing, at least those profit maximizing points, that gap has closed, right? But I kind of shut that down here because that just complicates it, right? We've got two things that would then be influencing competitive balance. Any other questions on that one? Or any other questions or the midterm problems that you want to take a look at?
Can you go over two?
Yeah, so I probably won't hammer as much on a problem like this. I would not expect something as similar. But the idea is we've got diminishing returns. We can always say, so what was it? Marginal, blah, blah, blah. So 40 hours a week on pitching, 20 on batting, right? So assume that diminishing returns for each skill are identical. Okay? So we've got the 40 hours a week, 20 hours practicing, exactly the same. Oh, so here we're thinking about when we choose to do things. Like I said, we didn't focus on this as much, so I probably wouldn't ask the question, but it is worth talking about because we got diminishing return. So kind of think about this as what we're trying to do is and here at dollar signs, kind of just representing the cost, right? So if I think about maybe putting an additional hour into pitching, well, I'm going to, like, let's say I start out, I put in no hours into practicing. My first hour, I'm going to choose whichever of these has the highest marginal utility per dollar, right? So if I said they both have the same rate of diminishing marginal utility, right, it must be that when I'm looking at the very first unit, the marginal unit for pitching divided by the price, if I'm choosing to put more hours into pitching, it must be that the cost is either lower or the marginal utility, you know, these marginal utilities are the same, then they must be higher, right? So we can kind of think about, this kind of gets tricky because they have the same slope, right? They're diminishing at the same rate. So it would have to look something like this, which would mean if the cost is an hour, it's whatever I would have done with that hour. So really, the kind of costs here are the same. We really just have kind of whatever our increasing marginal cost, putting an hour in at practices. So it must be that if I'm choosing 40 hours of pitching over 20 hours of batting, right? Or that's kind of where we think this was, think about this as the marginal utility or benefits. I said utility, this is really, you can think about this marginal benefits as well. It must be that this curve starts out at a higher point. Because if they have the same slope, there's no combination. If I didn't tell you they have the same slope, all bets are off because you could have something weird like this, or, you know, but if they have the same slope, you know that that first hour spent on pitching would have to be greater because they have the same slope. It's literally just like a linear shift. And you know that pitching was higher because I told you the kind of equilibrium number of hours they spent was higher. I wouldn't worry too much about a problem like this. We kind of talked about it more in the offensive, defensive talent and kind of thinking about the cost of talent there. But this is kind of what that one's getting at. Any other questions on those midterms?
You go over on number 7.
Yeah. Okay, so if the positive externalities that exist are greater than the negative externalities, there's two ways you could tackle this. So we did them individually. You could draw them both in the same graph, right? You can definitely do that. But it's going to lead to the same conclusions if you just draw, if you're just concerned with the number of games, you can just draw whichever is larger. So I'll kind of show that to you. So if you've got positive externalities, we said this meant that we've got some demand curve, which reflects the private marginal benefits. We've got some supply curve. The marginal social benefit, if we have positive externalities, would just be out here, right? It could be a point higher than the original demand curve. So the market, if we allow them to determine kind of what the equilibrium quantity is, it's going to be below the optimal quantity for society. Right? Now, I told you that there's positive and negative externalities. And I said, well, whichever is larger, you can just draw that one and you'll get the same conclusion. So here we've got that quantity is too high. Sorry, quantity is not too high. Quantity is too low. It should be higher. Right? You could also have done something like this. So here's kind of my original quantity. Maybe I've got positive externalities, but I've also got negative externalities. And I try to draw the negative externalities a little bit less of a shift because that's what I was told. Well, the new optimal point for society should be wherever marginal social benefit is equal to marginal social cost. We didn't go through any models where we had both of them, but that would be the idea. If we had both of them at the same time, we're making a decision based off of society's marginal cost and benefits. So you can see here, I end up with exactly the same conclusion. As long as I draw the shift that was larger as a larger shift. And the reason why is because I know that whichever one of these is larger, that's the effect that's always going to dominate, right? So the idea here was that with positive externalities, my quantity is too low. But if I only had negative externalities, where does my social cost hit demand? I didn't write this in, so here's demand. What would actually be that the quantity being played is too high with the negative externalities. But then if I simultaneously have these positive externalities, then if they are the shift that's larger, the fact that positive externalities result in that there's not enough games being played or not a high enough quantity, that would be the effect that rules out. So positive and negative externalities, they push kind of the socially efficient quantity in different directions. So whichever one of them is a larger shift, that's going to be the one that kind of wins out. So if you want to, you can just draw the one that you're told is larger. Yeah.
What's on the y-axis?
Yeah, so we're thinking about here, this is like the quantity of games being played. It's kind of hard, but it's like the dollar amount that the city pays or the dollar amount that is kind of being paid to host those games. It gets a little bit abstract because it's not like they're legitimately like paying every single game, but they at some point would pay a block or a large amount of money that would translate to these different dollar amounts per game. Yeah.
Kind of off topic, would you think that these externalities could actually play a role in increasing the number of games like we saw with NFL? Do you think they could play actually like a driving factor, like the MLB?
So here's, yeah, so I understand what you're saying. So here's the problem. Would the league, short answer is no. Long answer is no, because we're talking about this socially efficient quantity kind of theoretically. Like if the government could step in and do this, I don't expect the government to step in and tell the league to increase the number of games. And it's not that the problem is these externalities aren't people paying for this product, right? These are people, maybe they hate sports, but their restaurant is doing very well, right? Because they're located right next to the stadium. So the team or the league doesn't really have an incentive to increase the number of games unless maybe these positive externalities help convert some people so that they then do value the game. And so you see a shift in the demand curve, but the externalities themselves aren't actually going to cause there to be a higher number of games being played. We're talking about this as if society, if the city as a whole could determine what that quantity would be. Are we too high? Are we too low? If we just allow the teams and the consumers of their products to make the decision. It's a good question. Yeah.
Coming from like a negative perspective, though, do you think that would be possible?
Negative externalities?
Yeah.
Once again, unless it's translated through the cities putting pressure on the team or some type of, maybe not federal government, local government putting some pressure on these teams, then no, right? If the city sees negative externalities and they're so large that, I don't know, maybe they start to just cut back on how much they're willing to subsidize the team, which would then eventually cause the number of games played to go down because the team would go somewhere else, right? So I guess in that sense, the negative externalities could lead to a number of games being played to change. But, even with the negative externalities, we're not saying the quantity that's optimal is 0. So that would still be a bad thing for the city if the team, if the team did leave. So, yeah, it's really more so. Usually it's nice because we have the government steps in when we see these really obvious large positive and negative externalities, and they try to get our society to an optimal point, which rarely do they do things good, but externalities is a case where they can. The problem here is the government is pretty hesitant to just enter it or, come into a market and tell cities like, yeah, you should, or tell corporations, these different leagues, NFL, NBA, yeah, you should play a higher number of games. Like that's probably not going to happen. Any questions? Yeah.
Do we bring our own scrap paper or is it like?
Yeah, I'll bring a bunch of blank paper. You can write on the exam and obviously the short answer. I'll try to space it out with a short answer where there is room for you to write on the exam what your answer is, and then initial scrap paper, kind of identifying what problem it goes to. Any other questions? Yeah.
Would we need to bring a calculator?
Yeah, any math wouldn't be too terribly tough. So one of the problems that I had in the slides today, and we might not get to it, but it's very similar to kind of the one that was on your homework, kind of working through one of these like representative consumer models. This would be like the highest level math that you need to do. So I would bring a calculator just to, save yourself some time, prevent yourself from making kind of mental math errors. But yeah, the most math we're going to do is really, multiplying, subtracting, adding, maybe I don't even think that's divide anything. One thing I would review, I know we haven't talked in a while, thinking about dividing because you will actually have to divide something. And I'm not sure that this was in the midterms or midterm sample problems. I would go back, since you guys showed up, this is a helpful thing, right? So we had that ratio, which was whatever that standard deviation in wins was relative to the ideal standard deviation. Because we said as the number of games goes up, that standard deviation in wins that we can expect actually goes down. Each win is less of a swing. And so like that was the NFL. If we just looked at the standard deviation in win percentage, it's going to have the greatest one. But its ideal win percentage is also going to be the greatest, right? So the number of games that are played, right, kind of reduce the ideal standard deviation. And we kind of think about that ratio is going to be more like how close are we to the optimal point or the ideal point. So maybe kind of going back to your notes, finding that discussion and kind of reviewing the idea of kind of this ratio of the ideal to what the actual standard deviation win percentages are. I'm not sure that's really showed up in a lot of the problems or homework sets, but I know that's one thing since I've pretty much have the entire exam written, that might be a good thing to know. Okay. On top of that, I'm just going to give you some topics here. Maybe that would be actually helpful. I would know how to think about the ticket market. Think about shifts in demand for two scenarios. One where they're already at capacity, and one where they're under capacity. So we worked through a lot of problems or some of the homeworks. And then the other one would be shifts in capacity or that supply curve, right? So remember our ticket market, supply runs along the x-axis and then is vertical. Okay. And the same sort of idea, know how that would impact them when they're at capacity or under capacity from the previous scenario. Know how to like graph out the win market and kind of think about that win market. So some of the things that we thought about there were profit versus our win maximizing points. Right? We also thought about differences between large and small markets. And then kind of like I actually already went through, which was one that I actually had planned to go through a similar example, but also know how to depict revenue sharing with these average total revenue curves that are slightly higher than demand. Think about the shifts that occur for large market teams are larger if we're taking existing revenue. That might play a role in certain questions that you could be asked. Anything else in the win market? And just, I always try to throw this assumption in, right? This is where we always kind of had that assumed constant marginal cost just to simplify the model a little bit. So I'll always kind of give you that assumed constant marginal cost as well. Also in relationship to the ticket market, I would go back and review, and I put the answer key to homework 2 up there, but that problem where you had a representative consumer, I would expect you to see something very similar. Right now, I might do things differently than the one on the homework, but knowing models about doing single price monopolist, price discrimination, how do I determine what the valuation of the first versus the fourth ticket would be? Can I do bundling, like all that discussion? So that would be a really good one to review. Is that I think it was problem 2 on homework 2, maybe it was problem 3, but once you look on there, you'll kind of see that. I think there was probably one in the practice problems too. Maybe not. Let me see.
It was number.
Oh, right here, number 8. Yep. So something similar to 8. So it's got slightly different questions asked there as well. So that'd be a good one to review when you're thinking about trying to look at the ticket market. I think I had one here, like, 2 other models I know for sure you'll see. So know how to do kind of these game theory models where you're constructing the payoff matrix, right? So I think the models are pretty easy, and you kind of did them in 201. But I think creating the payoff matrix is something maybe you haven't been expected to do unless you took game theory. So going back and knowing how to do that. Yeah.
I was about to say that the extent of use.
Yeah. Just these normal form 2x2 games, and we'll do anything crazier. The only thing I would say pay attention to here is when we're thinking about these teams. If I gave you a slide, I think there's one in the practice problems. If you're told revenues and you're also told costs, so this is like examples where assume that Alabama spends $10 million more on I don't know, advertising, but that would bring in an additional $20 million of revenue. Sorry, they spent $10 million in advertising. The payoff would be $20 million in revenue. Well, when we think about the decision making of that team, the payoff really is profits. So anytime you're having strategies where it's thinking about spending more money, think about what you really need to do to calculate the payoffs is think about, okay, here's the revenues generated from this different combination of strategies, but here was the cost as well. So if you're looking at a model where you're told that they're spending additional money to generate this, you should be writing your payoffs in that matrix as the profits of each one of these different combinations of strategies. So for example, I think here, if 2 colleges are spending the same amount, 5 million, then they both earn 10. So what's both of their payoffs here? 10 million minus the 5 million, right? I would actually have profits of 5 million there. And then if one of them spends an additional 2.5, then their revenues go up by 5. So really, if I spend 2.5, now my total expenses are 7.5, but I made an additional 5, so I've got a total of 15 million. So my profits there would be 7.5. So sometimes there's a little bit more work to determine what your payoffs are in some of these types of game theory problems you might going to see. Any questions on that for keep moving? Another one that's kind of more recent, kind of going back and thinking about that tournament model where we were determining kind of optimal effort choices of different individuals. And really here, I think remembering that marginal revenue is always going to be your first place prize minus your second. So it's not the overall amount of the prizes, it's the difference between the two, right? And so if I have exactly the same prize for first and second, we said, unless there's some love for winning, if we're purely talking about money here, the effort level would be 0. I don't care if I get first or second. Right now, there are some intrinsic things that then we kind of generate. Maybe there's some it's not just revenue, right? We could build in utility as well. And if some utility comes not from money, but just from winning something, we could build that in, but kind of keeping it simplistic, just thinking about how the prize money will alter the effort level. We want to focus on the difference in the prizes there as our marginal revenue. Okay. So I think I wanted to mention a couple of these things. I know some of them were like in the practice problems, but some of them weren't as clearly or represented as much. So I would say kind of studying the best way to do this, go through those midterm practice problems, look at the answer key, make sure that, or figure out which ones you don't really understand. If you can't figure out from the answer key, I'll be around after class today till 4:30 in my office. Otherwise, tomorrow, I should be around most of the afternoon. I definitely will be there from 2 to 4, but if there's another time that kind of works for you, send me an email and we can kind of set something up then. Or even Thursday morning, I should be around if you want to kind of do some last minute questions Thursday before we meet. Feel free to shoot me an email to set something for them. But yeah, go through those midterm practice problems. And then after that, I would go back through the 2 homeworks, right? And I've got both of them up there on Canvas with the answer keys. I think that would be a good thing to kind of go back and review. Yeah.
Could you go over that example? You said something about the ratio, like the number of games over.
Oh, yeah. So we think about, let's say I've got kind of a standard deviation in wins. So this was the idea that, let's say, we got our ideal standard deviation. And that's going to be higher with the lower number of games we play. So let's say, I don't know, we've got this original scenario. Here's my ratio. And I don't know, let's say the ratio is 2.4. Okay. Let's say the NFL then, instead of having 16 game seasons, let's say they expand it to 17 like they did, right? Well, what's that going to do to my ideal standard deviation? We said that as the number of games goes up, this actually goes down, right? So if I kept the same win percentages, like let's say teams could somehow have the exact same, the standard deviation win percentages are the exact same in these 2 seasons, but that there was a higher number of games being played, then my ratio actually would improve. Even if performance of the teams didn't change at all, same standard deviation win percentages, but I'm playing a higher number of games, well, then that standard deviation needs to be kind of accounted for. The fact that I'm playing a high number of games would actually reduce the ideal standard deviation I should see. Right? So this is actually going to push the ratio further from 1. If nothing changed when I played more games, well, it should have been that standard deviations fell if they were getting closer to the ideal standard deviation. So just kind of knowing what that ratio is, how a higher number of games is going to influence. So think about this as the number of games goes up, our ideal standard deviation kind of goes down. Questions here? Yeah.
Would you want would it be better if the ratio is higher or lower?
So you want the ratio to be as close to 1 as possible. So think about it this way. The ideal scenario is calculating the standard deviation if every team won 50% of their games. Okay? So that's like your starting point. From there, you're not going to see that, right? You're not going to see. So you can almost think about it as the standard deviation that you observe in win percentages will always be greater than the ideal, right? Because we never have observed every team winning the exact same number of games. So the ratio will always be greater than 1, or sorry, not 0. I said it and wrote down the wrong number. Will always be like greater than 1. It could be equal to 1. If every team won exactly 50% of their games, then you would have the same number divided by the same number. But in practice, right, we actually see it deviate from that point. And so we're always going to have a ratio that's greater than 1. Getting closer to 1 represents better competitive balance. Yeah.
So number 12, when it asks why is MLB have a lower standard deviation than NBA because they have more games, basically.
Yeah, which one was that?
Number 12.
Okay, so there was one there. Yeah, so think about it's much lower in Major League Baseball, but they play twice as many games, so we would expect their ideal standard deviation not quite to be twice as low, but significantly lower. Yeah, that's what that's getting at. Forgot that problem was on there. I thought there wasn't one on there. Okay.
Yeah, also worded a bit differently because at the start it says that the NBA would be lower than the NFL, then later it says NFL is lower than the NBA.
Oh, really? Hold on. Let me see. There might be a typo in it. So standard deviation of win percentage is lower in Major League Baseball. Okay, so the ranking should be Major League Baseball, NBA, NFL, right? And we shouldn't be surprised by that because the ideal standard deviation as we go to like a higher and higher number of games should be lower, right? So then what does it say after that? Why is it misleading to say manager is less balanced than also NBA is less balanced? Oh, is this the part you're talking about?
Yeah, because then it says citing the reason because standard deviation percentage is lower than the NHL versus NBA, even though we just said that NHL.
Oh, so at the same time, why can you certain NBA is less balanced than NHL? Standard deviation percentage. No, this is right. This is NHL, right? So I then threw in a different league. I was making sure that when it said less and less. So what I'm getting at with the second part, right, is why can I directly compare just the win percent standard deviation for NHL and NBA? I would probably give an additional assumption here if it was on the exam. I was thinking that everyone know, but the number of games is exactly the same, right? So my ideal standard deviation should be the same. So there, I'm gonna have the same denominator. I can get away with just comparing that standard deviation wins because they have the same number of games. I won't assume that you know anything about these sports. So like I might give you some goofy assumptions on the exam. So on one like this, I would probably say, you know, it like started out with the NHL and the NBA have the same number of games. Or maybe I would have started out with the number of games played in the NFL is 16, the number of games in the NBA is 82, and so on and so forth. That way you have the information, and then I'm not just assuming that you know that. Any other questions? All right, so I did want to look at, maybe do some shameless plugs here. So this is the paper that we were going to look at last week. It's a paper that Professor Ness and I did. This is probably also another good example of a paper like yours. I wouldn't expect to be as long or as in detail, but just kind of the structure of it and like all these papers you've been looking through. This one will follow a similar structure. So, you know, we've got a little introduction, kind of also adds in some of that lit review. So I think this one they probably kind of molded. Here's the lit review after the introduction. So I discussed some of the other papers. We scroll down. What do we care about? We've got kind of these interesting regressions, right? So I have a bunch of other stuff in the slides, and I probably won't be able to give it as much time as I would have liked to, except for now I'm not on the slides. Here we go. But the general idea is, and there's a lot of research in a lot of different sports, but basketball is probably the most commonly looked at one. So let's say I'm interested in, shot made, right? So this is just going to be a 1-0 variable. Right? So whether or not the shot being taken is made. Right? And, you know, I probably think that depends on a lot of things. And so, you know, I could look at, you know, the score of the game or like the score differential. I could look at like all these other different things that I think matter. And then we'll call this. And then we're also going to say, okay, well, I think that players get hot, right? And I say n-1 here. So this is really like you can think about also maybe t-1. So you're just looking at whatever the previous shot taken, right? So going back one shot, was that made or not? So maybe there's a hot hand. Once I make one shot, I'm more likely to make the current shot. So if I'm looking at this coefficient, if I see that it's positive, that tells me that a 1 unit increase in my X variable, which here it's just 1, 0. So the unit increase is going from not making the shot to making the previous shot. So if I go from not making to making the previous shot, the expected increase in whether I make the current shot is just whatever this coefficient is. And if it's positive, that's what we would call a hot hand. That as I make a shot, I'm more likely to make the next shot. Okay? So this is the idea of kind of looking at this hot hand analysis. And in general, we say like flipping a coin, if I get heads on my first coin flip, I'm no more or less likely on the second one to get flip a heads, right? It's every time it's 50-50. Well, every player should have some innate underlying shooting ability. And as long as we can control for the other scenarios or the other circumstances around taking the shot, it should be that we actually see that this coefficient is equal to 0. Once I've controlled for all the factors, I have the same base underlying ability to make a shot. But now there's some more recent evidence, right? Coming from like neurology. Like I tried to read these papers and got very confused. But the general idea of what they found is that in movement patterns, they've identified that once you complete a movement pattern and once you're successful, so what they had them do is like they had a mouse and they had to like just put the mouse over like a bullseye. And they could only do with one motion. So sometimes they got really close, sometimes they're a little bit off. And what they found was that, and I think in one of them, they even blindfolded them so they couldn't see what they were doing. It's purely based off of the feel of the mouse and whether or not they're told you got on the bullseye or not. And they found that when you're successful in a physical movement, the neural pathways are strengthened on the subsequent movements. So if I complete this task well one time, I'm more likely to be able to complete it well the second time. Like these neural pathways get stronger, right? But it's only supported by success. Well, this is a perfect scenario. I'm doing a physical movement of shooting a basketball. If I took the exact same shot and I know that I was successful previously, my body's gonna like remember all those neurons that were firing, we're gonna remember exactly what they did to make that a successful shot. So, you know, people think maybe it's not a fallacy, right? When it comes to shooting, maybe there's this physiological mechanism. And a lot of people have looked at this. But the problem is if I'm doing this with shots in the game, so here I think S is whether or not they make the shot. S, I think I did I-1 here, so T-1, whatever, the previous shot. And then we controlled for kind of the overall shooting ability. So we basically took every shot outside of the current game and found out what that player's average shooting percentage was. That gave us a pretty good base of like, this is their underlying probability of making the shot, right? We controlled for a myriad of different things. I don't even remember all of them, but like all the game situational stuff. And we'll go down here and kind of look at some of the tables because they're kind of interesting. So if we're just looking at shots in the run of a game, well, the problem is there's a lot of other things to account for, right? We look at free throws, that's nice, right? But it also is a very specific one type of shot. We don't have any changes in location. And so maybe we don't really want to look at free throws either. So one thing that we did and some people have kind of done in the past is look at the 3-point shooting contest, right? Because I've got shots that are all of a pretty similar distance, so pretty similar difficulty. Now I'm moving from location to location. So when I change that location, are those neural pathways reset, right? So basically you can kind of look and see within, like in a 3-point contest, take 5 shots from the corner, 5 shots from, I think we called it, I think the wing, 5 shots from the top, another 5 shots from the other side of the wing, another 5 shots from the other corner, right? So do you see a hot hand within the location? Like, so maybe I start this thing off, I make my first shot, I'm more likely to make my second, more likely to make my third, fourth, fifth, but then when I go to that 6th shot and I switch locations, it doesn't matter that I made the previous 5 shots, that has 0 impact on whether or not I make that 6th one. Right? So we can kind of look at differences there, and does changing the location of the shot while also getting rid of a lot of other game factors, does it look like that gets rid of the hot hand? Okay. So initially we just run everything together and it looks like, oh yeah, the coefficient on whether or not I made the previous shot on my dependent variable of did I make the current shot is actually positive. So it looks like there's a hot hand that you're more likely to make the current shot about 5%. So this is probabilities of 0.05, right? Because we have a 1-0 dependent variable. So it increases the probability of making the shot by about 0.05 or 5% increase. However, if we break this down a little bit more, we could look at some of the other stuff. So here's whether or not I made the previous shot. And here's kind of, actually, let me show you a cleaner one. Here's a real nice one. So here, we've just interacted the number of, or whether or not the previous shot was made with what shot on the rack it is. So whether that's the 1st, 2nd, 3rd, 4th, or 5th. So because of location changes, if that impacts it at all, we might think that the coefficient on the made previous shot for the first shots might be different. Right? Sure enough, if we look here, it looks like for that 2nd shot, if I had made the first one, I'm about 5% more likely to make the 2nd shot. But then if I had made the 2nd shot, I'm about 9% more likely to make the first or third. If I made the third, I'm about 8% more likely to make the fourth. And for whatever reason, and my guess is here, we haven't come up with a good explanation, but what might be occurring on the fifth shot that they're taking that doesn't occur on shots 2, 3, and 4? It's the money ball. So this is actually, and it depends how far back you go in the 3-point contest. That fifth shot is actually worth 2 points. So we might have some like weird psychological thing going on there where like this matters more. So maybe there's a little bit of nervousness, but also anticipation of the next shot, because now anticipation of the next shot means I have to move. Why that didn't exist for shots 2, 3, and 4. Right? So maybe there's I'm not sure why it falls there, but those are probably good explanations, right? We can't really, it's hard to accurately measure what the psychological cost is. And then if you go to that very first shot, notice statistically, it's not any different from 0, and it's actually negative. Now, we can't say it's any different from 0, but it doesn't even show a positive effect. So this is just kind of a nice way of kind of supporting the hot hand, like in basketball. Like if you're taking shots from the same place and nothing else is changing, like you might see these neural pathways build. But as soon as you get a change, right? For hot hand fallacy to exist, we need otherwise independent identical events. As soon as we see people move shot location, the effect goes completely away. So it's kind of an interesting thing. We might revisit hot hand stuff. There's like another dozen papers out there on it that we could go over. This is kind of an introduction to one. So Thursday, show up. I'll be here a little bit early so we could get going a little bit early on the exam, give you a little bit more time. I don't even know if we have anyone that comes in after us. We're never like pushed out of here. So I'll try to give you as much time as possible. I'll bring extra paper. If you have any other questions or want to meet, feel free to send me an email over the next couple of days. And other than that, I'll see you guys on Thursday. Okay.